Hello and welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services based here in Europe, and I'm going to be your host for this session. This is one of our Journey Through the Cloud series webinars, and this series of webinars are intended to be solutions-orientated webinars that look at a variety of different AWS services, how you can apply those into common use cases that you may have within your organization. It's also intended to share some good practice that other customers have identified, and ideally really to help you learn some best practices that can help you bootstrap your own projects. We do have another series of webinars that we run here in the English language in the European time zone called the Masterclass series webinars, and these webinars are more of a deep dive orientated around individual AWS services. So if you're interested in learning more about AWS services in depth, you may want to check out the Masterclass series webinars that we run. Just some housekeeping before we start. So you can access the materials from this webinar after the session today. There'll be a files panel which appears on the screen during the Q&A period of the webinar, and you can download the slides that we've used today during that period, and we'll also send out a link to the slides on SlideShare after the session. Also, we record these webinars and make them available on YouTube, so we will also send out a link to the YouTube site. So if you want to re-watch the webinar or share it with any colleagues or customers or friends, then obviously you can do that. You can submit questions during the webinar today using the Q&A panel. Once my colleague switches the session into presenter mode, you'll be able to see that in a moment. And lastly, at the end of the session, you'll also be asked to provide some feedback and rate the webinar. So please do that. Your feedback's really valuable to us. Obviously, we're trying to optimize these sessions to make them as useful as possible to you. So if you've got any feedback on the session or you want to rate the session and let us know how we're doing, I would really appreciate that at the end of the session as well. You'll be able to see that again once we switch the webinar session into Q&A mode at the end. So that's the housekeeping. Let's move on and talk about the content for today. Obviously, we're focusing on cost optimization today and tricks and tips that you can exploit to minimize the amount of money that you spend on services with AWS. Slightly counterintuitive, but we're really keen here at Amazon Web Services to try and minimize what customers spend with us, help you retain some of your valuable capital and operational expenditure and use that for things which are more important within your business. So if you deliver your services using AWS services, essentially you can replace the sort of typical upfront capital model for buying IT hardware, software and services with this variable cost model that AWS offers. The economies of scale that AWS can drive as a result of its size, they can help you lower your costs, and it's important to understand how we go about reducing our costs over time. We'll talk a little bit about that during today's session. We have a variety of different pricing models that you can choose from to support either variable or stable workload patterns, and once again we'll cover that in some detail during the session today. And then lastly, this idea of volume breaks, where the more AWS resources you consume, the less cost per unit you'll incur for using those resources. And once again, we'll talk about that in some detail during the session today. So this is the agenda that we have for you today. We're going to take a look at AWS's pricing philosophy and talk about how AWS tries to minimize prices and the way in which we pass those price reductions on to customers. We're going to talk about some considerations that you need to have in mind when you do TCO comparisons. We're going to talk in detail about the AWS TCO calculator and how you can use that to assess and model the costs of delivering IT services using AWS. And then lastly, I guess in what you could regard as the main part of the session today, we're going to talk about cost optimization techniques on AWS and some tricks and tips that you can use to minimize the amount that you spend with us, as I said earlier. So let's get started. AWS pricing philosophy. We try to develop and spin this flywheel here at AWS, essentially trying to acquire customers, which helps us drive the amount of usage that we have on the AWS services. That allows us to, or forces us really, to acquire more infrastructure to service that demand. By getting bigger and leveraging that scale, we can drive economies of scale and innovate within our infrastructure platforms. That allows us to lower the unit costs of delivering that infrastructure, which enables us to reduce prices. We pass those price reductions on to customers. That hopefully helps us acquire more customers, so we drive more usage, so we can drive more infrastructure, so we can leverage those economies of scale, so we can lower our infrastructure costs and pass those price reductions on to customers. And that's the flywheel that we're trying to spin at AWS as we scale up our business and adoption of AWS grows around the world. And that's enabled us to proactively reduce the price of our services 45 times since our launch in 2006. We'll give a few examples of that later in the session today. But we proactively do that. We proactively pass those savings on to customers in the form of low prices, and we seek to continuously reduce prices as we deliver services to customers over their lifetime. So that's an important characteristic of AWS that you need to bear in mind when you're doing TCO comparisons against more traditional IT delivery models. And the characteristics of that low price model really are fourfold. So the first thing is this idea that you can replace upfront capital expenses with lower variable costs. And some work that was done by IDC towards the end of last year, where they were looking at the business value of AWS. They did quite a large survey of larger users of Amazon Web Services. And they discovered that on average, customers were replacing around about 400 physical servers with services that they were deciding to use from AWS rather than buying that equipment. So you can see there there's actually a large number of customers that are really doing that. They really are stopping spending capital on infrastructure, and instead they're consuming services using this variable usage-based charging model that AWS operates. Secondly, the economies of scale that we just talked about a second ago in that flywheel construct, that allows AWS to continuously lower our costs. And as we've said, we've had those 45 price reductions since we started delivering services in 2006. Thirdly, there's some choice in the pricing model that you use. So you can self-optimize your cost base, and we're going to talk about this quite extensively in the last section of the webinar when we come to talk about cost optimization techniques. But you can self-optimize your cost base, matching your purchasing model to the characteristics of the services that you're using. So if you know you've got for example, a long-term workload that's going to run for quite a long period of time, you can opt to buy the resources for that workload using reserved instances and other types of reservation purchasing model, which will drive down the hourly cost of those resources for you in return for making that commitment. So you have some options that you can use to further optimize your costs depending upon what your particular workload profile is. And fourthly, the more resources you consume, the less your unit cost per resource will be. So this manifests itself in the form of things like volume discounts within the Amazon S3 storage service, where you go through certain volume breaks and your cost per gigabyte for storing your data will be reduced according to the amount of total volume that you have. And that applies not only to the excess, if you like, the amount of capacity that you have that's above the volume break, but it also applies to all of the capacity that you already have. So your unit costs will fall over time as your usage scales up. And what these things combine together to lead to is this reality that your costs for delivering services with AWS are typically going to be significantly lower than either a traditional on-premises data center, where you're going to have a pretty heavy CapEx component because your infrastructure is going to be used in quite an inefficient way, and is even better than an on-premises virtualized data center, where you may have more efficient resource utilization, packing more operating system instances onto your compute nodes, for example, your physical compute nodes, for example. But you still have that CapEx component, and you still lack some of the agility that you can typically drive from operating in the AWS Cloud. So combining together the scale that AWS has, which helps us drive down those unit costs, the high levels of utilization that we're able to drive by, we call it aggregating non-correlated workloads, but it means basically merging together demand from lots of different customers with different workload profiles onto the same infrastructure platform and getting reuse. So where you might have a retailer that's busy during the day and a bank that's performing intensive batch operations at night, if you can let those workloads coexist on the same platform, the same physical platform, then they're happy neighbors whose workload profiles are counter to one another and will allow you to get much higher levels of aggregate utilization out of your infrastructure over time, and therefore drive lower cost per unit of infrastructure consumed. And then lastly, we don't talk a whole lot about this, but we also do a lot of work to optimize the technology stacks that we use and to optimize the supply chain that we use. So as we get bigger, we obviously have volume breaks that we can exploit ourselves within our supply chain. We can also invest in optimizing the technology that we use to make it as fit as possible for the services that we're delivering on it, and once again drive down those unit costs. So you combine those three things together, you'll typically find that AWS is significantly lower cost than either your on-premises data center or an on-premises virtualized data center. And it's not just an AWS viewpoint. This has been validated by quite a few external parties. One of the best points of external validation is this AWS commissioned IDC research, where IDC did a TCO study on behalf of AWS. And if you follow the link at the bottom of the slide here, which you can of course access if you download the materials after the session, you can access that report and read a lot more about the detail of how that study was conducted and what its findings were. But in essence, 72% 5-year TCO savings were the average that were identified across the large organizations that were sampled for that particular piece of research. So it's well worth checking that out. And of course, if you're going to start with a position where you've got better cost efficiency in the platform, the longer your utilization duration is for the services where you're getting that cost advantage, the more benefit you will drive versus traditional infrastructure. So you can see here that customers that have been with AWS for long periods of time typically tend to drive more cost benefit than customers that are using AWS only for short periods of time. So you can consider this as a viable platform for long-term workloads as well as for workloads that are bursty or spiky in nature. And a great example of a customer that talks about this quite extensively is Flipboard. And the reason that it's a great example is because you can see there from those metrics at the bottom of the slide here, a very clear representation of how their costs per user have fallen as their monthly active users have increased. So this is combining together those factors that we talked about of the efficiency of the platform, the scale of the platform, and also the idea that those volume breaks kick in. So as you get bigger, you typically pay less per unit of consumed resource. And you can see that's having a really big effect on Flipboard, and it's lowered their cost by at least a factor of 4, if not more, since they launched their service in June 2010, running up to February 2014. They've seen a really significant reduction in their cost per user to serve. And you've got very, very low cost to serve there, as you can see on the left-hand axis. And later in the deck, we'll show you a slide with some references on it where you can take a look at a video of one of the engineering leads from Flipboard talking about precisely how they've managed to deliver this cost efficiency by using AWS services. So we'll come to those references at the end of the deck today. So we'll move on now and take a look at some considerations for TCO comparison, things that you need to bear in mind when you come to compare the costs of AWS versus the costs of on-premise IT delivery. And the first thing to say is that this isn't necessarily easy, okay? So there's a lot of factors at play here that need to be considered. Comparing TCO in general is not easy, and we're going to just try and state a few things that you need to look for in order to make sure that you've got a complete comparison of TCO on-premises versus the Amazon Web Services Cloud. So the first thing to say is that you can have quite a lot of overhead costs when you're thinking about delivering services from traditional data centers. And some of those overhead costs can be hidden in other cost lines that aren't necessarily IT cost lines. So it's important to have a good appreciation of the full picture of where all of your costs are before you start a TCO comparison exercise. And you can see here an example actually of some of the less obvious components that you may have to consider in your cost model when you're thinking about what the costs of buying hardware and operating on your own premises are versus the costs of using services from AWS, from the AWS Cloud. So, and it's quite common for hardware vendors, for example, when they come to do their TCO comparisons, only to consider the acquisition cost and maintenance costs of the hardware and compare that against AWS services and say, oh look, we're definitely cheaper. But they'd fail to consider the fact that there's a lot of other components that are outside of the acquisition cost and maintenance costs of the hardware that you also need to bear in mind. So to build a full delivery platform of the type that AWS operates, you're going to have to consider way more stuff than just the server and network hardware. You've got software, the data centers themselves, powering and cooling the data centers, inefficiency that you might have to deal with, like storage redundancy, for example. And then you've got management software, network infrastructure to hang it all together. And of course, you've got data center personnel that need to operate it as well. So there's a lot of hidden costs there that need to be considered. And in your TCO analysis, you might want to consider this as a kind of bucket list of things that you need to look at to factor into your TCO model when you're comparing cloud-based delivery versus on-premises IT delivery. So take that away as a quick reference maybe, and think about the benefits side of the case as well. So what are the benefits that you can drive if you can access a platform of the type that AWS has and use some of those agility and speed benefits that customers tell us they like so much when they use AWS. So the TCO calculator itself provides a wizard-based tool for helping you work out the costs of operating on-premises IT infrastructure and comparing that against the costs of using AWS services. And this has recently been refreshed. So if you visit the TCO calculator, and I'll show you a link at the end of the section where you can find that, you'll be asked to enter the characteristics of your environment. And it's a good idea to break this down, and if you can break it down, and do it application by application, because you may have relatively complex infrastructure organized by application in your environment. You can break it down by application and then use that to phase an app by app migration program if that's what you want to operate. And the TCO calculator will spit you out a set of calculations which show you a more complete set of costs for running your infrastructure on your premises versus the complete cost for running your infrastructure within AWS. And they'll phase that over a 3-year period for you. And it'll include a lot of those hidden or less obvious components that we talked about in that last section there. So looking at things like storage inefficiency, looking at things like the bandwidth utilization that you have, and also helping you match your compute resources onto current AWS instance types that might be appropriate for you to run your workload on. And it'll show you a cost breakdown of what your cost base will be either for your on-premises or for your AWS-based delivery option. It will also give you a detailed breakdown with all of those costs made visible. And obviously, you can use that to check assumptions and validate those detailed costs against your own knowledge of what your own costs are. So it's a super tool for looking at in order to validate whether or not a move to AWS might offer you TCO benefit. Of course, if you dig into the tool, you can access the full details of all of the calculations that have been used to work out the cost model. There's a full explanation of the methodology that's been used. There's also a full set of assumptions, which you can, of course, as I've just said, validate. And there's frequently asked questions there. And of course, if you've got any more questions, you could submit those via the contact links that are visible within the TCO tool. And let us know if you think the tool needs to be enhanced or amended in any way. And to access it, you just follow the link that you can see at the bottom of this slide. And this will be repeated later on when we come to the resources slide at the end of the session. So one example of a customer that's been through this process is Dow Jones International, or more correctly maybe News Corporation. Now, News Corporation are in the middle of a very large migration to AWS at the moment, where they are essentially going to vacate 34 of their 40 global data centers. They're going to migrate about 3,000 applications to AWS. They're intending to complete that migration by January next year, so they're well underway in undertaking this activity. And their TCO modeling shows that they're going to save themselves about $100 million over the next 3 years as a result of that migration. So a good example of a very large customer that's been through a comprehensive TCO modeling exercise and calculated a really tangible financial case for moving a large proportion of their applications to the AWS Cloud. And if you want to find out more about that particular example, if you follow the video that you can see at the bottom of the screen there, you can see a video from last year's reInvent where one of the technology heads within News Corporation talks quite extensively about what they're looking to achieve and what they anticipate the benefits will be. So check that video out if you want to learn more about that. So now going to move on to what you might consider the main section of the webinar today, where we're going to get a little bit more technical and talk about cost optimization techniques that you can use to minimize how much you spend on services from Amazon Web Services. And I think there's 10 or so different topics that we're going to talk about here. So we'll go through these 10 topics in a little bit of detail. Of course, if you've got questions about these as we go through them, please type those into the Q&A panel that you can see in the webinar interface, and we'll come back to your questions at the end of the session today. So the first thing to say is it's important to choose the right instance types for your workload. And what that means really is that you should start by choosing an instance that you feel best meets your basic requirements. And it's a good idea to size on memory in the first instance and then choose the closest match of virtual cores, okay? And also to be aware of what your peak IOPS requirements are going to be for storage, and make sure that you're choosing an instance which has the capability to deliver those IOPS. So if that's an EBS optimized instance, or you're making use of the new general purpose SSD volumes, there's some techniques that you can use there for high performance workloads and also for cost optimization of storage intensive workloads, IO intensive workloads. So make sure that you're looking at those as aspects of your instance selection. Once you've got your instances running with your application on them, it's very simple, of course, to resize instances, and you may do this before your application's live in a pre-production load testing period. It's very simple for you to resize an instance up or down on the basis of metrics that you can gather using the CloudWatch tool or using a Trusted Advisor assessment, and we'll come to talk about Trusted Advisor later in today's session. But you should definitely look to optimize your instances before you put your app into production to make sure that you've got the right balance of performance and of course price. So minimizing your costs while making sure that you've got enough performance headroom to deliver the user experience that you want to deliver. Once you've done that tuning exercise, then it's the right time to roll out your application and to run the multiple instances that you need to ensure that you've got the right availability strategy for your application, and that's blended with those correct instance types that you've selected. And this isn't just a one-off exercise. You need to stay current and stay aware of new AWS instance types that could potentially offer you better price performance characteristics. And just a couple of examples of that. So we recently announced a new T2 series family, which is a series of instances that offers an ability to burst CPU performance. And this replaced something called the T1 Micro, which was the previous generation smallest instance that we had. And also it overlaps with some of the M1 family, so the small and medium M1 series family. So we're replacing instances that have traditionally been at the bottom end of the instance families that we've had. And these new instances are significantly more cost effective in terms of cost per hour to run than the instances that they replace. And they also offer better performance. So it's a sensible move in that particular scenario to migrate away from those old instances onto the new ones. You can potentially run on smaller instances, which will cost you money, but even if it costs you less money, but even if you're running on an instance which is equivalent in size, the new instances are at lower cost anyway. So be aware of new instances as they're launched and evaluate those instances against your workload. And if it makes sense for you to move in order to make sure that your costs are optimal, then do so. It's not a painful process in most cases. The second thing to say about instances, of course, is that you can use auto scaling. So you can automatically add and remove instances from your auto scaling groups, what we call these collections of instances that have these auto scaling policies applied to them. And that will enable you to automatically match the amount of capacity that you have to the amount of demand that you currently have for your application or for your workload. And you can use metrics from CloudWatch to drive this auto-scaling activity. A very common example would be auto-scaling on the basis of CPU usage. So you're taking a look at the metrics across your auto-scaling group. When you breach a threshold, say 80% CPU for more than 10 minutes, you would add additional instances. Now that ensures that the application performance expectations of your customers are still met, or of your users are still met. But if you have low utilization, say lower than 30% utilization for 15 minutes, you can automatically remove instances from your auto-scaling group and automatically scale your costs down. So it's a very important tool that you can use to add and remove EC2 compute capacity as you need it. And again, matching that price performance, those two price performance characteristics against one another, making sure that you're delivering acceptable or good user experiences, whilst at the same time making sure that your cost is as optimal as possible. And one little trick you might want to bear in mind when you're doing this is to consider the instance types that you use. So here you're looking at a workload profile which is being supported by M1 large instances, so the old style or first generation larger instance family. And you can see there that the scaling is quite blocky. So we're adding resources, but when we add those resources in, when they're first added, they're not particularly heavily utilized. And in fact, when we're at peak load, we've got a couple of instances there that you can see that are only utilized very lightly. And there's a significant cost benefit to be gained if you use smaller instance types in your auto-scaling groups, because it allows your capacity to more accurately reflect the amount of demand that you have. So you're more accurately matching capacity against the metrics that you're seeing from CloudWatch. And here you can see that same workload is being serviced with M1 small instances. Sure, there are more instances, but there's also less underutilization of instances, and for that reason the dollar cost of running the workload with this smaller instance family is significantly lower, and you can see the cost comparison there at the top right, $6.96 versus $3.54. So just consider what the scaling chunks are that you're going to use with auto scaling and try to make those as granular as possible. You'll see that can help you optimize your costs. It's also important to think about how you turn off instances that aren't used, that might not be instances that are metric driven via auto-scaling groups. So some examples of that would be things like development and test instances, where your development and test teams might only be working core hours, so 8 to 10 hours a day, maybe not working at the weekends. Well, it's very simple with AWS to shut down environments when they're not required and rehydrate them, reactivate them when your development team comes back into the office on the Monday morning. So that's a great way to save money in development and test environments. So we've got a whole webinar that we recorded earlier in the year where we talk specifically about development and test workloads on AWS and go into more detail about how you can use techniques like that to minimize your costs. So take a look at your infrastructure and the assets that you have and establish whether there are areas, components of your compute resources that might not be required throughout the week, so you can tear those down and reduce your costs. And using tools like AWS Cloud Formation, OpsWorks, and other automation tools, it's very simple and very efficient to automate the recreation of environments when you might need them in a very consistent state. So take a look at some of the tools that are available to help it easier for you to spin up and spin down your environments on demand. And one of those tools is using CloudWatch metrics to simply shut down instances. So you can see here examples of a CloudWatch alarm being created that will stop an instance if it's significantly underutilized for a long period of time. And that's something that you might want to do in your development environments, just as a catch-all to catch instances that might not have been stopped by developers but have been left idle. You can put those stop actions on those instances. They'll be shut down and hibernated effectively when they're underutilized for long periods, and if a developer needs them, they can reactivate them again via the console or via the command line. So that's a good technique that you can use for reducing cost overruns as well. And fourthly, also in the compute area, you might want to consider using RIs. Well, in fact, you should definitely consider using RIs if you have steady state workloads. That's a reserved instance, by the way, in RI. And what this allows you to do essentially is to pay an upfront fee and reserve capacity for a 1 or 3 year period. And in return for paying that upfront fee, you get a significant discount on the hourly rate for the instances. and they don't have to be utilised 100% of the day. There's several different bands there that you can see. Heavy utilisation RIs, they are intended for workloads that are active 24 hours a day. Medium utilisation, they're intended for workloads that are active over 60% of the day. And light utilisation are intended for workloads that are active, say, 30 to 60% of the day. So you can blend those different RI types together, pay variable amounts up front for the different utilisation levels, but in any event, your hourly costs will be reduced in return for that upfront payment. You can see on the left there that you can drive up to 65% savings on your compute resources by using RI purchasing for them. So it's a super tool to use to minimize the costs of running compute workloads. And it doesn't just apply to EC2, it also applies to RDS, so you can prepay and reserve your RDS instances. I just did this myself last week from my personal blog. I prepaid for a year's worth of T2 micro instance to run the MySQL environment from my blog. I think it cost me $57 for the year to do that. So it's a very, very cost-effective tool for reserving RDS instances. You can also reserve capacity on DynamoDB. You can reserve Redshift clusters. If you have data warehousing workloads that you want to run in AWS, you can do those on the reserved clusters as well. And you can reserve Elasticache clusters that you might use for accelerating the performance of applications that need to access relational data sources by using caching. So you've got several options there for reserving services, which can help you drive down costs. And this is something that you definitely need to consider in your TCO model. So whenever you do a TCO model for a long duration workload, you must consider using RIs in order to minimize the TCO for that workload. Okay, so that's reserved instances. That's a very, very important tool. Fifthly, you can add to that something called Spot. And Spot instances are a mechanism for bidding on EC2 capacity that's currently unutilized. So you can see if you go into the console, the current bid price for EC2 instances of various types. And you can place a bid for those EC2 resources. And if your bid is higher than the current minimum bid price, you will be granted those resources. They'll be made available to you for you to run your compute workloads on until your reservation expires. So you've had as long as you want from those instances, or your bid is no longer above the minimum bid threshold, at which point those instances will be reclaimed from you. So it's good for workloads which are not time critical and are not sensitive to interruption. There's several AWS services that are integrated with Spot instances, probably the most notable of which is Amazon's Elastic MapReduce, the Hadoop managed service. And with EMR, it's possible to build a Hadoop cluster which comprises both on-demand instances or reserved instances and Spot instances, which can help you accelerate the completion of Hadoop jobs and can reduce your total cost to run those jobs by blending those Spot instance resources together with those other instance types that I talked about, or the purchasing models that I talked about. So if you have a workload of that type, you can definitely take a look at Spot and use that as a mechanism for accelerating delivery of your workload and also lowering your costs. And customers have done some pretty phenomenal things with Spot instances. Maybe one of the best examples of this is an AWS partner called Cycle Computing. And Cycle Computing deliver high-performance computing clusters which are built on AWS resources, and they commonly use Spot resources for this. And they ran one particular workload last year, which was for an end user called Schrödinger, who are a biomaterial science research company. And this particular workload was involved with the assessment of photovoltaic materials. So they were looking at materials that are used in creating solar cells. And they built a cluster comprising 16,788 EC2 instances, which was capable of 1.2 petaflops, that's peta floating point operations per second. And they delivered 264 years of computing resources in less than 18 hours. They had about 156,000 Intel CPU cores in this cluster while it was running. It was one of the largest supercomputers in the world while it was in operation. And that cost $33,000 from the spot market to execute that workload. So heavily discounted as a result of it being acquired from the spot market. and a very, very cost-efficient way to run large-scale computing jobs. The cost of building that, by the way, with capital investment would have been about $68 million. So it's a very, very efficient way of running large-scale computing jobs. And if you have HPC or analytics workloads where you need to apply a lot of computing resource to a particular challenge, then the spot market might be a good way for you to do that in a cost-efficient way. Sixthly, storage. So there's several different storage classes available, for example, on Amazon S3. The default, something called reduced redundancy storage, and a service called Amazon Glacier. And these storage classes can give you opportunities to optimize your costs for storing data. RRS, or reduced redundancy storage, it reduces the durability of S3 from 11 nines to 4 nines. And it offers up to 20% savings in return for doing that. And why might you use it? Well, it's a good target to use for large volumes of data that can be reproduced. So a good example of this would be, for example, transcoded media, where you might have high resolution masters, 4K or 1080p masters of video, but you might want to transcode that down to 720, 364 and other line resolutions for play out on different devices, or to use as thumbnails in another application. Well, you could store those transcoded videos in RRS, would reduce your costs, and if you needed to reproduce them, you could reproduce them from the master on demand. So it's a good example of using RRS. We also have Glacier, which is a high durability service in the same way as S3, offering 11 nines of durability. And Glacier provides a low cost option for archiving long-term backups and retaining data that you might need to keep for regulatory reasons. It's intended for read never applications, so it's only really intended for applications where you need to infrequently access your data, or very infrequently access your data. You have a 3 to 5 hour restore time in order to retrieve data from Glacier, at which point it'll be placed back in an S3 bucket for you to access. And it costs roughly 1 cent per gigabyte per month to store data in Glacier, so it's significantly lower cost than S3, even lower cost than S3 RRS. So if you've got data that you want to archive and you want to really minimize your cost for doing that, you could consider Amazon Glacier as a good target for that. Seventhly, architecture offload. So this is a mechanism for minimizing the amount of EC2 capacity that you need. So getting some aspects of your application literally off EC2 and onto other AWS services that might be more cost efficient. One example would be, for example, to use the Amazon CloudFront content distribution network to serve frequently accessed content assets out to users of your application. Not necessarily just static assets like images or static HTML, but also things like CSS or JavaScript assets could be delivered by CloudFront. That can significantly reduce the amount of EC2 resources that you need, and therefore reduce your bill. Similar things at the back end, by using Elasticache, you can significantly reduce the size of RDS instances that you might need to run by serving the majority of database queries out of that in-memory cache rather than out of your RDS instances. So there's several techniques that you can use to offload workload from your EC2 instances and have that workload carried by other AWS services that might have better cost characteristics. And if that's something that you want to investigate, we'll show you some resources at the end of the session where you can learn more about other AWS services and how you can potentially achieve those kind of offload techniques. And if you have questions about that, submit a question via the platform. We'll get one of our solutions architects to follow up with you if it's a detailed question. There's definitely an opportunity to offload and use less EC2, smaller RDS instances, and use other AWS services where it's appropriate to do so. And that extends into application services as well. So typically you could choose to run open source or commercial software packages on your EC2 instances to provide things like queuing services, or to handle email delivery, or to handle notification services. Amazon Web Services offers service options for many of these architectural artifacts that you might include within your apps, and many of these are available to you in the free tier, so you can test and trial these application services and establish whether they work for you at no cost. And they're all available with the same sort of usage-based, capacity-based pricing model as all AWS services. So Pick an example like the simple queuing service. You could choose to build your own message queue and maintain that across a number of EC2 instances. Or you could use the simple queuing service, which will cost you 50 cents per million API requests. So if you've got applications that you're building that can take advantage of these application services, you can certainly look at that as a mechanism for, once again, reducing the amount of EC2 capacity that you might need to use within your application. And that extends to network services as well. And here's a cost example of building your own load balancing service using EC2 instances versus using the AWS Elastic Load Balancer service to deliver that load balancing functionality. You can see the cost example there. The AWS ELB is under half the price of building your own software load balancer on EC2 instances. So it's a good idea to look at the full portfolio of AWS services, establish where you can potentially use them within your architecture, and if there's a cost benefit from doing so, then grab that cost benefit and take advantage of it. Another trick that you can use to reduce your costs, as we've talked about already, is this idea of volume-based discounts. And one of the disadvantages, I guess, really, of having lots of separate AWS accounts, for example, for different environments or for different projects within your business, is your usage is fragmented. So you could potentially fail to take advantage of some of those volume discounts because it's done by account, obviously. There's a technique that you can use for avoiding that issue, which is to use something called consolidated billing. With consolidated billing, you have a master account within your AWS environment, and you link your other AWS accounts into that master account, and the billing for those other accounts will flow up into that master account, which is where you will pay your bills from. But volume discounting, for example, for RIs or for benefits from, for example, having large volumes of data stored in S3, those will accrue in that consolidated billing account. So you can still split your accounts up and have them separated to help you control costs or delegate management of those accounts to different individuals within your organization. And if you use this consolidated billing technique, you can still take advantage of volume discounting, and you can share RIs across different accounts as well by purchasing your RIs in that master account and then having them contrad off your bill in that master. So a great way to take advantage of your scale, even if you have a large number of different AWS accounts that are controlled by different entities or different individuals or associated with different projects that you might be running. And then lastly, on these tips for cost optimization, some tools that you can use. Maybe one of the most important is an AWS tool called Trusted Advisor. And Trusted Advisor have actually announced recently that several of the checks within Trusted Advisor are now available free of charge to all AWS users. Some of them are still reserved for customers that are using business or enterprise support. You may just want to take a look at that announcement, which was put on the AWS blog a couple of weeks ago, and read the detail. But in essence, Trusted Advisor provides automated recommendations that you can take advantage of in order to improve your AWS account. When I say improve your AWS account, it covers 4 different scope areas that you can see here. So cost optimization is one, and that's what we're talking about today, obviously, but also performance, security, and fault tolerance are also addressed by Trusted Advisor. And what it will do in the cost optimization is it will take a look at your utilization, and it will establish whether you have instances that are substantially underutilized, and if you do, it will alert you to that. It will take a look if you have instances that could potentially be converted to RIs, and you could make a saving by making that conversion. So it's a very worthwhile tool to take a look at. And with business support, you don't have to commit to business support for a long period of time. You can take business support for 1 or 2 months, paying from $100 a month for that service. You can look at the recommendations that are generated while you have it in Trusted Advisor, and you can implement those recommendations, and then you can cease your business support, and in a year's time you can activate it again, and once again you can take advantage of the recommendations that it makes. So it doesn't have to be a service that is permanently activated. Obviously you'll get benefits if it's permanently activated from the support center, being able to use the support teams and being able to review these recommendations day by day and week by week. But if you want to test it or try it out, then you can do that with no commitment, no long-term commitment. So take a look at business support and take a look at Trusted Advisor and see if that works for you and provides value for you. And another enhancement that is slightly less recent, this came about 3 months ago, is something called AWS EC2 usage reports. This provides details about how you're using instances, how heavily utilized they are, how your breakdown of different instance hours goes by different instance types. So it's another useful tool that you can take a look at in order to establish whether your usage of EC2 is optimal. Okay, so that concludes cost optimization techniques. Just to quickly recap, so the 10 things that we talked about there: choosing the right instance type and making that an ongoing process that you assess that you're using the right instance type over time, using auto scaling to turn up and turn down the amount of capacity that you have in response to metrics, making sure that you switch off unused instances that might be in development environments, and of course using tools for automating that and using tools for automating the recreation of those environments as well. Using RIs, reserved instances, to minimize the cost of long-term workloads or longer-term workloads, and using spot instances to minimize the cost of short-term workloads, and techniques for blending those with other instance types, for example, using EMR to do that. Leveraging different storage classes, using a combination of S3, RRS, Glacier, and of course the different storage options that are available for EBS to make sure that your storage costs are optimized. Offloading your architecture by reducing the amount of EC2 resources that you need by using AWS services like CloudFront, S3, Elasticache, and others. Using application services for similar effect, so you may opt not to build some application components as services yourself, but rather use AWS services to deliver those, queuing, notifications, and other services. Using consolidated billing to allow you to take advantage of volume discounting and to share reserved instances across different AWS sub-accounts that you might have. And then lastly, leveraging some of those AWS cost management tools, Trusted Advisor and EC2 usage reports to get visibility and through visibility get control of your AWS costs and enable you to optimize those. Okay, so that concludes everything that we have today for you in terms of content. Here are some useful resources that you might want to take a look at. And obviously, if you download the slides from the files panel of the webinar, you can access these. The Economics Center, which is where you can go for everything cost related in AWS. The TCO calculator, which is the tool that we talked about in the session today, which will help you model the costs of on-premises delivery versus the cost of using AWS for those services. And then 2 really good reference videos, one from Flipboard where they talk about reducing the cost to serve per Flipboard user over time, and one from News Corporation where they talk about their plans for data center migration into AWS and some of the financial benefits they're going to get from that. Quite different customers, I think you'll find. One is obviously a high growth startup operating in the mobile app space, and the other one is a more traditional enterprise that is moving customers onto AWS, moving services onto AWS. So contrasting, but very similar themes there, and well worth taking a look at those 2 references. So here's what we covered today. TCO summary really was to take a look at how you can make reasonable assumptions and use that TCO tool to leverage industry benchmarks, and knowing about your on-premises hidden costs, power, real estate, cooling, all of the other services that wrap around your data center, and making sure you factor those into your TCO modeling. And in cost optimization, we spent quite a bit of time looking at different techniques that you can use to build cost-aware architectures, best practices that you can leverage to minimize your costs, revisiting and re-evaluating your architecture often, for example in EC2 instance selection, using application services from AWS, including CloudWatch. And it's important to stay up to date with what AWS are releasing in terms of RI modifications, Trusted Advisor, and new instance types. So you might also want to take a look at a couple of things I'm going to show you in a second on keeping up to date with AWS. Just close by saying that if you want to learn more about AWS services, there are training options available to you. So you can take AWS self-paced labs to get some hands-on experience with AWS services. You can take AWS classroom-based training from AWS and also from partners. If you go to aws.amazon.com/training, you'll find a global course catalogue there of all of AWS's training offerings around the world. So you might want to investigate that if you're interested in learning more, for example, about offloading your architecture or using some of those AWS application services. Those education offerings are a great place to go to learn more about that. And you can validate that education now with AWS's certification program, becoming an AWS certified solutions architect or an AWS certified developer or systems operation professional. So if you're interested in certs, take a look at that. And if you want to stay up to date with what AWS are up to, one of the best ways to do that is to follow some of our social media accounts. So you can find me at Ian M if you're interested in what I'm up to here in the evangelism team here in Europe. You can follow us at AWS_UKI to keep up to date with AWS here in Europe in the English language. Stay up to date with news and events that might be relevant to you and also launches that might be relevant to you. And if you want up-to-the-minute information about AWS service launches, global events, customer references and the like, then find us at AWS Cloud on Twitter, and you can follow that account. That's got nearly 100,000 followers and is the sort of canon source really for new service launches that AWS announces. It's quite good to get in the office in the morning if you're in Europe and take a look at it. You'll often find there's 4 or 5 services that have been announced during the night, which can be a nice surprise when you come into work in the morning. So that concludes today's session. We're going to take a look at some questions now. Not a whole lot of questions today, so if you do have questions, please submit them. I'd love to get your feedback as well in the questions panel. And we'll take a look at a few of these questions and see if there's a couple that we can answer now on the webinar. So there's a question here, would you recommend using T2 with the Elastic Load Balancer? So you don't choose the instance type that underpins the Elastic Load Balancer. The Elastic Load Balancer is a service that AWS provides. So we presumably use EC2 instances to underpin it. I'm not actually sure about that. So it's a service that's provided and traffic will be delivered onto the instances that are registered with the load balancer. You don't have to worry about scaling it, and you don't have to worry about what kind of instances that are used underneath it, if indeed they are. What I would say about the T2 instances, if you've got an existing workload that is running on a T1 micro or on an M1 instance, either a small or medium M1 instance, then you should look at migrating those onto the T2 instance family. They're going to be more cost effective in terms of price performance, and they're also just going to be more cost effective in terms of cents per hour charging because they're lower on both metrics. So it's a good idea to migrate onto T2s if you can do that as quickly as possible. I actually migrated, as I said, my blog onto a T2 RDS instance and the front end of my blog onto a T2 micro just last week. It's a pretty painless process. It took me about 2 hours to do it. So it's not particularly tricky, and that included porting myself out of Bitnami WordPress into a standalone WordPress installation. So it's not a big job to do the migration. You need to be using something called HVM instances in order to do that. I've actually got another question about HVM armies. So it says the question is, what is the difference between HVM and PV instances? And it's asking about what type can performance be guaranteed. So with the latest instance families, so the T2 and the M3 and the C3 instance families, ideally you should be using the HVM armies. And the reason for that is the hardware virtualization mode. It offers better price performance, so it will deliver better CPU performance. It also offers single root I/O virtualization, SRIOV. And SRIOV is an enhanced networking driver that delivers better packets per second throughput on the instances. And that is also included within those HVM armies. So it's definitely a good idea to use HVM in preference to PV. If the instance family supports HVM, we would recommend it. You get better price performance and better network performance by doing that. Okay, take another question. We have a test server currently running on a T1 micro. Do we recommend upgrading it to T2 and turning it off? Yeah, definitely. So definitely upgrade it to a T2 micro and then definitely turn the instance off when it's not in use. If it's not a RI which is purchased on heavy utilization, you won't pay anything for the instance when it's not running other than a small amount for the storage of the volumes that are associated with the instance. So you'll be paying EBS charges for your idle root volume and any data volumes that you've got that are sitting there idle, but you certainly won't be paying the hourly charge for the instance while it's not running. So you should definitely switch them off if they're not in use. Also saves power. Okay, let's see what else we have. Okay, the question here about the granularity chart for auto scaling. So lots of small instances versus a few big ones. He's saying it's applicable for web traffic, i.e. web servers. If you've got a big database spike, how does the model fit? So you're right, we're talking here about a kind of trade-off between what you could call a scale-out architecture and what you could call a scale-up architecture. And you're, I guess, talking about databases there that fit in that scale-up architectural model, which don't necessarily lend themselves to horizontal scaling, in other words, adding new nodes. And you're absolutely right. Those would typically not be in auto-scaling groups. We typically recommend running them on RDS, or of course running them on EC2 instances. If you want to manage the database software, maintenance of the software yourself, and backups yourself, you can of course do that. And you're correct that the database needs to be sized for peak load, but you can still of course get a saving in your front end tier and in your application server tier if you have it, which are tiers which are more likely to be, let's say, friendly towards horizontal scaling techniques. So you're correct. Of course, there are now different database technologies that you can use that do lend themselves to horizontal scaling, and we're talking here about NoSQL database technologies that you might opt to deploy, where you can add and remove nodes from the data tier. These are typically what you call eventual consistency database technologies, so not necessarily ACID. And I guess if you're talking about relational databases with those scale-up models, then you're probably going to want that. So the scale-out architectural construct probably isn't so applicable in that kind of model. Okay, we're pretty much out of time here, so we're going to wrap up at that. There are a few questions that haven't been answered. I'm going to extract the questions from the webinar today and I'm going to send them over to our SA team, our solutions architecture team. And if you've submitted a question today, you'll receive an answer within the next 4 to 5 days in writing, in email. And if you are unhappy or you want further info, just reply to us. We'll come back to you with additional info and make sure that you've got what you need in terms of answering your questions. Okay, so I'm sorry we didn't get to everyone. There's actually quite a lot of questions came in late in the session which we didn't get to. So I'd like to thank you once again for your attention today and for joining the session. I'm just going to pop a link up on your screen so you can see the upcoming sessions that we have. So check out this webpage. There's my lovely picture, but check out this webpage after the session and you can take a look at what we have coming up next. Big data analysis on the 9th of September. Then on the 7th of October, we're going to be looking at security best practices on AWS. So please take a look at upcoming webinars and join us if you think those might be of use to you. Thanks again for joining the session, and please don't forget to either rate us using the poll that you can see there, or add a comment in the questions if you want to leave some quality feedback. Thanks very much for your attention today. Thanks for joining the session. Bye-bye.